job usually they want people who have worked for 1 year, especially into operations. Okay. So, like today, I just want to cover the basics of networks. Those the terms you can see on the screen. And but before that, the job profile, something it says about operations, and so the other end of the operation is your development work. That we are usually software companies do. So these are two, uh, two parts of. Two sections in any software department. One is creating a software and managing the software. So, so the developers are usually dealing with creating the software, uploading it to Git, checking in, checking out, and the operation team is usually responsible to take the code, whatever that code is tested on the development environment or on the development boxes, into the main box, which is your production boxes we see. So in between, if there is any testing done by the different set of testing team, then the testing team also comes in between. But these three are essentially the development team is involved in the development. So they work on different set of computers, which is outside your production network. And testing team will take the code from the gate or somewhere, using the some kind of a code pipeline. So these days we have DevOps, right? So where continuous delivery and continuous integration is happening. So continuous integration means a lot of developers are working on different modules and they're keeping on uploading the code. And as and when it is tested, and testing team keeps on, as and when, in testing also there is two types, automated testing and manual testing. So these days people don't have time to test everything. If somebody makes a change, then it can bring down the entire system. It is quite possible one variable will not be initialized or something, and that's why you cannot keep on testing the entire product every time, right? So that's why we have automated tested, where every time some changes are done, like basic one basic set of automated testing has to be done. So automated testing requires programming also. So you need to program as to what button to click, what data to provide, and what website to open. So all this comes under automated testing, and it requires programming knowledge. So this is a very highly demanded skill in testing area, and these days the testing has become more difficult because you need to test on different devices. Then you have desktops, you have you have other devices, like like if it is like tablets or mobiles, or those are the basic set of devices. But also if you look into a bigger application which involves, like internet and your sensors, which is used in IoT, so the data may be coming in from different sources, not only from your all your computers, but also from your mobile phone, your watches. As you're putting your watch, somebody is running your blood pressure, your different attributes about your health is being tracked by that watch. And so there are so all these kind of devices are coming. There are a lot of smart devices around the world, no? So there is TVs there, which is a smart TV, which is kind of can be connected over the internet. You can talk over the talk to anyone over your internet. That is called voice over IP. So data is flowing from all many directions, and it can come from any number of devices. So that's why these terms of IoT or IoE is also coming up. So testing, how do you test all these different types of applications? It definitely becomes difficult. So to the least, then one has to rely on automated testing. Operation part is basically usually there may be a release team or a PMO team. So PMO team is like, you can say a group of managers, who will decide for the business that what product, what features will be released and what features will not be released. So release team is like, they are more responsible to follow the steps of the follow the steps for releasing a particular feature. So sometimes, let's say you are doing a database change. So database change, the SQL server may already be installed. If it is the first time this release is happening, then you need to specify the steps, like the database has to be installed, and then after that a table has to be created. You have to run this script. So you need to initialize the database even before you start. And the second time you release, then you have to be careful that you don't override any any old data, and there is no loss of data. So release teams, basically you can say, are part of operation teams itself. And so they take over this steps. So they who are providing these steps is provides definitely these steps have to be provided by the development team. So in development team also we have programmers and architects and managers, right? At this level. So they each programmer has to at least provide a set of test cases, or what all needs to be. If it something, usually programmers are usually involved with only programming a module or something, but architects may be involved in mentioning which component has to be released, in what order it has to be released, when the web server has to be released. Especially when there is a multi-tier architecture, the steps have to be correctly followed. And what are the testing that has to be done pre-release and post-release? Like, post-release also you have to verify. So post-release is more like a black box testing, where you have to, you visit a website, you create an account, you carry out a simple $1 transaction and make sure it is working fine in production. So all those steps has to be provided by the development team. And but in development team it depends on the hierarchy of who is leading that module, or maybe as a manager is responsible, development manager is responsible for that module. Then that person, everybody in the line has to do the verification checks. So it does not mean the groups are if one team is totally responsible for everything. It goes through these phases. Even the testing team is looking at what the development team is doing, even the PMO team is looking at what everybody else is doing, and even the release team is looking at what everybody else is doing. And that is where your operations comes in. So in your operation, it is not only about software, but it is also about hardwares, right? So hardwares and softwares, and the licenses around it. And if it is like hardware, then we are dealing with networks, infrastructure, servers, softwares, licenses. Everything is included. So it is it is not only software operations we are talking about. We are also talking about hardware operations. So that is where the term operation associate comes in. And they want people who can look into the network needs, the infrastructure needs. And it is more of a, you can say, the hardware side, and a little bit of DevOps, and little bit of cloud tools like CloudFormation. So CloudFormation is basically, you can say, you can or you can write the code as to what hardware has to be installed and what software has to be installed in a CloudFormation template. It is less just like coding. So it is all usually called IaaC. So the operation team usually may have the IaaC code, infrastructure as a code they may have. So it is so when you say infrastructure as a code, it means you don't have to literally now move machines or something. All the physical layout of network is given to you. All the physical machines are given to you, but now you need to write a code as to what type of machines you want, what operating system you want. what type of storage and database you want on that. And so basically you're writing the code. So this is a very important skill nowadays for cloud. So cloud formation is one type of service which you can use, and there are other softwares like such as Terra, or then there is Terraform, I think it is called Terraform, and then there is Ansible, and there is Chef over here, Chef and Puppet over here. So all these tools are not only used to, cloud formation is specifically for AWS, but Terraform is like a more of a neutral IaaC infrastructure as a code. So remember, whenever somebody says IA, so there is like we have in services, we have like IaaS, PaaS and SaaS, but this is we are talking about IaaA. C. Then so there is also known as CaaS, something known as configuration as a service. So basically, the idea that is anything that you want to do in the cloud, it should not be about manually picking up servers, manually putting in cables and everything. All that setup should be there, the physical infrastructure. On the top of that, you virtually create networks, you virtually create computers, you virtually detach something and attach it to something else. You take the computer from one network, put it into another network. You take one computer and you expand the storage capacity, the memory capacity, the network bandwidth. The needs can be anything in the infrastructure. So the main skills then in operations becomes like, can you program it? Can you everything has to be programmed, everything has to be tested. So just like earlier days, testing was only manual, but now it is automated with programming. In operation also nowadays, all the hardware, everything that you want to set up has to be programmed, has to be there has to be a way to test it also. So we are looking at looking at everything as a software. We are looking at infrastructure. We are trying to build the infrastructure by writing a software program. So that is what this work will mostly be all about. To creating networks. So one is you need to have the knowledge of the networks and the infrastructure, but other component is how do you program it, and that is why you have to learn tools like CloudFormation, Terraform or Ansible. So CloudForm, as I told you, CloudFormation is AWS specific, but when you come to Terraform and Ansible, they are like cloud neutral. So which means whatever scripts you are writing, this is also like IaaC, but it can be that code sorry, that code can be used on any cloud network. So this becomes very when you write a code in Ansible, Terraform, then it becomes a very big advantage where your code is common for both the types of clouds. It doesn't matter, it is like a open standard, and so there is a common way of telling, the machines have to be added or removed or created, something like that. So when you have a multi-cloud solution where some part of your software is running in AWS and some part of your software services are running even hardware also, hardware and software. So just move to make sure recording. So when you may have hardware and software services distributed across multiple clouds, then should we go for CloudFormation? The answer ideally would be no. The answer would be you would go for Terraform or Ansible. So Ansible is the most latest one which I've heard about. And Chef and Puppet is also used, in this operation process. And but Chef and Puppet is more, I think, license driven, and even Ansible has cost involved with it. And Terraform is, I think, kind of an open source. You can use it, without paying, much or not paying at all. So there is a lot of demand for a tool like Terraform nowadays. So as operation person, you as I told you, one is the basic knowledge of networks and infrastructure. That is one part you need to know. The second part is about programming part. How do you program this using IAC, CAS, So now in CAS, what can come? Your security also come in CAS, because you have to configure. So how do we configure? Where do we configure? How do we track whether configuration changes have happened? Or which IP addresses have come in. So you should not be have to manually sit and watch out for everything or implement everything. You have to automate everything. So automation is a key skill in cloud. Everything has to be, and for automation you have to program it. That is the only way out, and you have to use the tools to program it. So any questions on whatever I shared about operation, development, IAC, CAAS, CloudFormation, Terraform, PMO. PMO is like Program Management Office. Okay. So whenever you are in any office, at least in big companies, they will have a program management office to manage the business. They are between the business and the technical people. So business people don't understand technical terms, so they go to program management office and they say we have this requirement, so requirement, and then program management and portfolio management, they say okay, this year we'll do this so and so project, so and so issues will be resolved, and this is the list of things we'll do, and this is the budget that will manage. So this is all about program, you can say project management, program management, portfolio management. All this comes under your management, but this management is specifically cater more aligned towards business folks. So and on the other side, the PMO works with these days we have business analyst, we have system analyst. So these people are like a kind of more knowledgeable about business side and technical side. So these are like dual talented, especially the BA people. So so they are like dual skills. They don't need like major programming skills, but they need to understand technically how things are done. And when the technical person is talking about something, they should understand, and that is very important. When they're talking about a website or at least a basic thing, so they don't have to be they have to able to create high level designs, documents, and the low level design document is usually created by the development team, but the high level design is usually created by the business analyst. So so this is one like whatever I'm explaining is also I'm explaining you how the companies are organized, and who is responsible for what skill sets are important, and it will also help you understand when you meet some somebody in that role, or you're thinking about going into that role for whatever purpose. So many non-programmers, they who are technical, like people who don't want to program, but they have done the technical degrees. They try to go towards BA side because it is less technical, less programming. And and there are people who go into testing thinking there is no programming at all. That line is actually that difference of line is almost gone away. You have to know automated testing, so tools like Selenium, and so those are the tools. You have to know how to program using these tools. So any questions on what type of job, so this, as I told you, this is mainly there are 50 positions over there, and I was hoping that somebody, whoever doesn't have jobs, they get it. And usually they are looking for 1 year experience, and this is for AWS, so it is definitely a good company. They are paying a very good salary, and definitely the increment will be good. But this is a kind of work, you'll be working with clients of AWS, customers of AWS, which is at the enterprise level, which is at the small businesses, or maybe only one customer, or a basic startup. So you may have all types of organizations, and businesses across the world that usually the operation systems will be dealing with. So they work with AWS partner network, who who are like, you can say, AWS partner network usually have solution architects in them, as part of their teams, and these are basically private individuals. Let's say I am a solution architect, so I can become a partner of AWS and become a part of their network, like Amazon partner network. And whenever anybody has a problem in AWS, I can, AWS can recommend anybody from the partner network like me. And definitely, when I'm providing my services, then I get paid, through for that particular service. But definitely, I am a private individual. I'm not AWS. I'm not like employee of AWS. So. And definitely the partner network in turn may work with the operation team internally to AWS. And so in AWS, you have to understand there is physical infrastructure also that has to be maintained. So there is in fact, a separate course in new course that has come up in data center infrastructure, which has not been, I don't know, they're not talking much about this, but sooner or later I may share it with people who are into network security and data center infrastructure, because I feel that is the nearest you're getting to the infrastructure, physical infrastructure. So somebody has to monitor that also, right, at the physical infrastructure level. Any questions? Is everybody able to hear what I'm saying?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So now that we have understood, the type of job profile we're looking at, it is not exactly the programming job, but programming is involved. So here in this, you will also have your DevOps. Okay. So when you come with DevOps, then it is all about creating your pipelines. Basically, pipeline is basically code will come from one end, and it will get from the development side, and it will be tested automatically, and it will be released in the production, but it will be done automatically. So one has to know how to use these services, like, especially there are softwares like Jenkins, which is used to automate this process. It is like writing a batch file where all the, we are writing all the commands in the batch file to execute one after the other, create this file, move this file. So Jenkins also is similar, but it is more across, it tries to connect all the the process itself, the process from the development to the testing to the release. So that entire process is whatever I said, people are involved at doing this, it has to be done automatically, and that is what DevOps is all about. So DevOps, it is quite possible DevOps may pick up a script of Terraform and install some virtual infrastructure, create some machines, or put some operating system. So it can be one of the steps in DevOps. So these teams, usually you will find, many companies which we, especially who are small, want to grow big, and things are becoming bigger and complicated. Definitely, this is something which you can recommend, even as a, even though you are a development side. A lot of companies may not have all this knowledge, and that is a time you can say, we can have a DevOps operation, we can move to the cloud. And because whenever we use DevOps or we move to the cloud, things happen quickly. And you can talk about the migration strategy, how, whether we migrate the data, we can do it in incremental steps, just don't shift everything, so I have a migration strategy. So even though you are not part of the operation teams, there may be times when you may have the knowledge, and it is very good to give the knowledge also. And it doesn't mean you become a role, just you may be in the development team, but you may be also be like that, conduit, like a conductor between the development and the operation team. So your knowledge and your skills, especially even if you do few experiments with this operation side, website, it is extremely like an add-on, very useful feature, a skill set, which is required almost, many a times, it is the need of the hour, because you have to constantly release something in the production, right? And so operation skills is these days also very important for DevOps. So the very word DevOps means developer plus operations. It is a automation. It is a bridge where the line between developer and operation is going away. So a developer doesn't say I am from the development team. Neither the operation team says I am from the operation team. So DevOps is basically used to eliminate the operation team actually. So an ideal DevOps environment will be where operation team doesn't exist, because everything is automated and the developer just pushing in the code and everything happens smoothly. But in the real world, definitely one has to look into what has been released, and you need to have a physical set of eyes looking into things, and that's why they definitely have DevOps engineers, to support this kind of work. So it is not, we cannot eliminate totally the human presence, in this, whatever we configure, whatever we install, whatever we trying to secure, whatever we try to protect. So humanize is very important, and that is where our role comes in. Okay, so so let me move on to the next topic. Basically, so I wanted to talk a little bit basics about networking. So most of you must have been gone through these basics, and it may must have been taught to you. But I wanted to make sure if you all are asked these terms inside the interview, because these are the kind of terms they're going to ask you for a 1 year experienced person. What is this, what is that, but the basics of networking. They may not ask you whatever I spoke to you about now. This is like at a higher company level, but definitely when you're getting into network operation side, they may have questions, simple questions, and they may expect you to know about it, and they are looking for mostly with 1 year experience. If and But even if you don't have 1 year experience, and but maybe you can apply and uh, maybe impress them from your interview and get the job, because the job profile I feel is not going to be very tough once you get hang on of these things. Once you configure this, and then you don't have to keep on changing things in the system. You have to just keep on monitoring for it, and just respond to any issues that comes up for whatever reason. Okay, can anybody tell anything about these terms? How are all these connected? Devices, NIC. So NIC is your network interface card. Cables, hubs, switches, routers, internet, DNS web. Can anybody speak a little bit? What Well, I've done networking. That's what I'm trying to understand. How well you all were taught, because uh, if you do not know this, then that means your subject, either you have not, you need to study. Then these are the basics. So can anybody talk about this infrastructure? This is at the more at the physical layer, physical infrastructure. How are all these terms connected? You, Anuj,
So I know some of them like switches and routers.
just tell me what you understand. Let's start with maybe. Okay, Priscilla, do you have any idea about these terms, or is it something you're going blank on this?
So I have studied this in layers. So,
Sorry.
I have studied this in layers, as you said, like with regards to layers.
Okay.
Yeah.
But right now, it is like a blank thing for you, right? When you're hearing these talks, you don't know what it is used for, what how it is connected, right? Can I assume that?
No, I don't know the connection between.
Okay. Uh, Alak, can you want to try? Is it something for you also? These are terms are coming across as new.
Sub Palak is not there.
Oh, Palak is not there. Okay.
Yeah.
Anuj, so Anuj, you know little bit. You said what you know. You tell me.
Like sir, DNS is a domain name server. Actually, there was a lot of IP addresses, so it was hard to identify them. So that is why there is a server.
Okay. Tuba, you want to give it
Yeah,
what?
for DNS, right?
No, for everything. Like how is all these terms connected?
Okay. Network is our network is where two devices connect to each other through IP addressing. Cables are the Ethernet cables that they're referring to here, through which we're able to connect the network. It's either through Wi-Fi or through Ethernet, right? So I think they mean that those cables here, and web hubs are used for broadcasting traffic. They're actually a dummy piece, square shaped, uh, through which, if you connect a switch or a router, they'll just broadcast the traffic to all the other devices that are connected to the hub.
Okay.
Whereas switches are layer 2 devices and routers are layer 3 devices. Switches are used to internally communicate within the organization, whereas routers can also be used as firewalls um, to broadcast the traffic out of the organization. And routing can be done in routers as well as firewalls. And internet is cloud. DNS is domain name server, where the IP address is converted to names. Like if you type google.com in layman language, the computer fetches it in the background to 8888, that is Google's IP address, because machines usually understand the IP address language. Domain name server just converts the IP addresses to names and names to IP address. That's about it.
Okay. So yeah, thank you, Tuba. So I will try to explain it. Just wanted to let you all know this is not my area of expertise. But I still felt whatever knowledge I give you, it will add on to your understanding and make you a better engineer and increase your opportunity. So that's why I'm going ahead and just explaining in my world how do I see things, so that you can connect these pieces together. So whenever we are talking about devices, we are talking about a computer, or a phone or any device, digital device. So you can assume there is a device over here and there is a device over here. So networking is all about sending information from A to B. That is all about networking. So how do you send this data? That is what is the answer to to everything that you're studying about networking. But essentially what you're trying to do, you're trying to send information from A to B, so something like that. So when we are talking about devices, so then it may be a desktop, a desktop to desktop, right? Or it may be a desktop to server. It can be any combinations over here, right? It can be a mainframe, you know. It can be a IoT sensor. It can be a watch. So devices, there is no limit, what as to what devices we are talking about. Today we are in an age of internet of everything, which means internet of not only when we say earlier, when we used to say device to device communication, we were referring to computers and maximum a tablet, or laptop. maybe something of those kind. But these days the devices also means smart devices, which is like your washing machine, your TV, your cars, and then you have IoT sensors, which are like minute temperature sensors. These are not like computers, right? So but these are so whether they are analog or digital, whether they are IP or non IP. So usually in when we talk about a digital world, we are talking about IP devices. So even if you're having a camera, let's say a security camera, that camera can be an analog or a digital. It can be IP based or a non IP based, right? So we computers cannot talk to each other without the IP addresses. IP address is like your address of the device. Who are you, where are you, how do I reach you. Those are the things. The IP address helps you get to you, or connect to you. When anybody has to connect to you, they have to, you need the IP addresses for sure. So we are talking about digital devices, but digital devices are coming in all types of varieties, and we are trying to build an application where we have a combination of everything. So networking is become little complex, but at the basic level, everything is still the same. Everything is IP to IP, right? One IP address to another IP address. So when we talk about IP address, definitely there are two types: IPv4 and IPv6. So IP, you can think about IPv4 as the range is a smaller range of addresses, like let's say 0 to 1000, but IPv6 is like 0 to 10 lakhs. You can have that many addresses. Now why will one require IPv6? Because the number of devices have increased. Now we don't only have the computers, we have the sensors everywhere. So in just one house, we may have 4 computers, 4 phones, and 10 sensors. Doing all your machines and everything. Everything is a smart device these days. So you are having at least 40 to 50 things operating in your house, and they may be operating in a network through your Wi-Fi. They may be talking to each other also. A washing machine can talk to a TV. A TV can send a message to your computer. Your computer can send a message to your phone. Everything is possible. It is all about networking. So the basics of networks have not changed. It is still IP to IP. It is still device to device, and that is what you need to understand. Devices. So at a very basic level, we are looking at device on one end and the device at the other end. Now the question is, where the device is. Is it inside your home? Is it inside your company? Is it inside your lab? Is it across the building? Is it across within the city? Is it within your country? Is it beyond your country? So that is all about your networking, right? So how do all these things connect to each other at the hardware level? So this is very important. So even though even before we think about internet, we have to think about how these wires are connected to each other, right? Are we connected through a cable wire? Are we connected through a Wi-Fi connection? Wi-Fi is like a connection through your air, right? Are we connected through even a remote also, right? When you are remote, when you press a thing on remote and you send, you press a button, you are sending data of in the form of your infrared waves, right? And Wi-Fi, you're using probably radio waves, and if you're using a cable, then it is a direct line, like a telephone line. So if you're using a Wi-Fi, then it depends upon what type of medium you're using. Are you using satellites or something? And then are you using lower end orbit satellite, or are you using higher end orbit satellite? Then there is a project called Starlink now, which where Elon Musk is trying to create an internet between moon and earth and Mars also. So somebody from the earth can send a message to moon also, and so that project is Starlink is going on. So but at the basic level, we are talking about device to device communication. And how do you do that? Because ultimately it is just a piece of wire, right? Or is it is just a piece of your a signal, a blink, like a torchlight. So when you want to put a particular message, on the torchlight, I think it is called Morse code or something, right? You gives that is like data. So in fiber optic technology, what are we using? We are using light. Your just like your tube light, the light, the photons are coming up. We are using light as a source of your connection in fiber optics. It is made, your material is made up of your glass and plastic, and your light is sent to it, and the blink of light is telling you it is like a torchlight. Then one time it blinks or two times in a second blinks, it means A. If three times it blinks, it may mean B. So all this flickering of light is happening in a fiber optic cable, and light is much faster than sound, and sound is much faster than maybe your as your normal line of wire. So you may the speeds may vary depending upon what is carrying the information. And then now these days we have quantum computers, where we are using quantum physics to transfer the data even without using the medium, using some techniques which is called entanglement and everything. So quantum computers are also coming, where there is nothing in between, but something, it is like magic, like something happens in like two, like a, let's say there are twin brothers or twin sisters, where something happens to one person, the other person feels it. That is like quantum effect, and that also is there. So but ultimately at the end of the process, what we are looking at, we need to send information. It is wanting to know, like it is just like sending letters. Okay, so whom are we sending to, how do we send it, to what mode of transmission I will use. Will I use a postal? If I'm using a postal, will I use registered post or normal post? If I'm using registered, then I want an acknowledgement. So all these things are there even in your networking. So that is why you have to understand everything starts at the device level. Then this particular device called NIC, network interface card, is something which is mapped to every network interface card. So how so definitely everybody has seen a device, so like a computer they have seen. So I will not show how a computer looks like, how the device looks like, but if you see this diagram, this is like your network interface card. So there is a point where you're connecting over here, and then there is a, this is like a whole board of your programming board. You can say a PCB board with is probably may have its own processor, maybe may have its own storage. It is like a computer in itself. It depends on your how complex advanced your network interface card is. But this fellow is important to connect your device to anything else, then in the process. So you have to keep that in mind. So every device definitely will have a NIC, network interface card. So when you say I am taking a NIC and moving it from one computer to another computer, basically what happens is NIC is usually you may have a particular address also. So the NIC address, when you take a NIC, let's say I take the NIC, the address of NIC is 1, and I take this NIC card and I put it in this computer. So then the address of B will become 1. Okay, so this uh, so this is very useful when when we don't want to, when we want to change the device but we don't want to change the address. So this kind of NICs in the AWS world is they are called elastic NICs, where you can move the NICs across your virtual machines. So this is like your card over here. Okay, NIC card. Every computer, most of the time, they will have this NIC card over here. And as I told you, NIC, every device or NIC, this is a combination where basically device plus NIC. They will have an address, and what is that address called? Anybody knows? What is that address called? So that address is called a MAC address, medium access control or something. So you can look at that MAC address, and let's see whether we can get MAC address of this computer or something. So this is your MAC address over here, the physical address. So we are talking about device, right? It is a hardware, it is a physical device. So for that physical device, this is the MAC address. So this so every computer device has an NIC, every NIC has a MAC address. So remember that. We are not even come to the level of IP address right now. Now we are the hardware level only. Well, just two devices have to talk to each other, then they have to know the MAC addresses. So now the thing is, we how do we so we can probably connect a wire from from this computer to another computer over here. So this can be your, this is where your cables are coming in, right? So this is what is cables. I spoke how I told you what how it is connected. So that is where your cables are coming in. Then what is the next term? Is your hubs, right? Now hubs is two computer, maybe this may just work out for you, okay? But now what do you do if you have a three computers? How do you do that? And that is the time you come into okay, how do we connect all the computers? What is the network topology we'll use? So that those are the question marks that comes on, and this is where your your hub can be here in the center, which is used to connect all the computers. So it is like your your like your central common station, like from Dadar hub you can go to Central Railway also, Western Railway also, that way. Sorry, so if you have three computers, then it is all the matter of connecting to the hubs, right? Central hub. So this kind of topology, so this is hub. So so what is this topology called? Network topology, this way of designing networks. What?
So is it mesh?
No. Let me show you. I don't know whether the diagram is there. So you see this diagram. Looking at this diagram, tell me what is the topology I have shown you just now. Sorry, hold on. Which topology it is closely matching to?
So bus.
Bus, no. It is looking like a star, no?
So
Yeah.
star.
So this is your star. This topology is called star topology. This is the way you're connecting on the computers. So you may be asked this kind of terms, talk about network topologies. So you can talk about star topology, and then you can talk about mesh topology. We can look at that later. But right now, what I wanted to emphasize is where is the hub coming in the picture. So this hub, can also. So this is the point where you are connecting computers now, more computers, and this is where all the other devices come, your switches come in over here, your routers can come in over here, you know so these are basically connecting multiple computers, okay. So that is where all the other devices, switches and routers are coming into place. So I hope you understood this basic network, at least how, at least at some level you have to understand, okay, this is how things are working over here, okay. Now, at this point, you have to also understand that MAC address is helping you tell which device you want to connect. So, when you have this kind of a network where you have literally, let's say in your house, you have a hub over your switch or whatever router, whatever it is, and then you're connecting three devices to it through whatever means. Either you're using a cable, either you're using your Wi-Fi connection, either you're using whatever medium of connection, communication channel you're using. Every device in that network will have a MAC address. Okay, so that is your physical address. This is my physical device. It is like looking at your, taking your laptop comes and in the behind there's an IMEI number. So it is a unique number given to it. So in the same way, NICs will be given a particular MAC address. But apart from this, the second addressing which is there, which is given, is the IP address, which it is not meant at the hardware level. Actually, at the hardware level, I don't need IP addresses. IP address is where it is required then. For device to device communication, I am connecting. It is like two phones are there, two ends of the phones are there, and we create that game, right, where we have glass, your paper glasses, and then you connect a thread in that. Those are like your devices. MAC addresses is the max that you will use at the device to device communication and the hardware to hardware communication level. When you dealing with hardware to hardware communication, you're dealing with wires, you're dealing with pins, and you're dealing with signals, voltages, and everything. So that is where this network interface card is more about connecting hardware to hardware. Your connection using through IP MAC addresses via hub switches and maybe routers. But what is IP addresses then used for? IP address is used for mostly at the application level, you can say. So let's say you have a word application, and for example, you're playing a PUBG game, for example, where it is, let's say, the one this that is the application you're using, and there are two computers on the other side. So these computers, they don't understand hardware. They don't know that there's a phone on the other side, or whether there is a computer on the desktop on the other side. They don't know. What they know is the IP address. IP addresses are that's why IP addresses is something, it can you can your MAC addresses is like your permanent hardware inside your your permanent address for the device. So that's why it is more of a permanent and physical address. So this is your more of a physical address, but IP addresses are more of a logical address. So as I told you, IP addresses can be in IPv4 format or IPv6 format. It is just like using a standard. This is how I will specify about my address. So usually when we talk about addresses, we may talk about, let's say, pin numbers. In a pin code, it may be a particular type of addressing, or maybe in some other place, pin number may be not the way to express a location. Maybe latitude, longitude is a way to express a location, because now we are talking about moon and earth and everything. Then when the pin codes may not work, no. So we are now interstellar now. Interstellar means we are within the planetary system. We want internet. People will be traveling here and there. So we have so many devices all across the world. So we do not know, someday now IPv6 also will get exhausted or not. We don't know. But right now IPv6 is a very big number, and IPv6 is a very small range. And even IPv4 is a very big range, but it is much smaller than IPv6. But IP addresses is something that you can change. So IP addresses you can assign. One time you can go inside the computer and say the IP address of my computer is 10.10.10.10, something like this. So this is your I am giving the address over here. So that is what is called static address. But let's say I am connecting to my phone, and the phone is connected to devices. So let's say your phone is also like your router, no? So like you are broadcasting your internet over here, and so that phone is connecting all your devices through some authentication. You're giving your password and everything, and this phone has to know which all devices are connecting to it and what all data it is requesting, what it is actually looking out for, what are you browsing, etc., everything, right? So it goes through that Wi-Fi router, which may be part of your phone, which may be part of your computer, it may be a different devices over all together. But in any case, this router has to make sure everybody has a IP address. So even though you have given if you are not giving a static IP address, the router itself will give you a address. So router will say I am I am 198.100.0.1. I am this IP address, and I am so whenever the moment A connects, authenticates, and connects, like let's say you have a computer and you're connecting to for internet purpose, you're connecting through your phone router. This address will be given by whom? By the router, right? And so this fellow might get 100 point in a sequence it will get. So this is number 2. It will never most likely it will be in a sequence only. 198.100.0.3, and this fellow will get 190 IP address, 198.100.0.4. Now what happens if your phone is switched off, if your internet is off? What happens to the IP address? The IP address may go away, and second time when you want to you switch on, maybe you get a different set of IP addresses. So this time when the router is assigning the IP address, some this fellow gets 198.100.0.1, but this fellow gets a different address this time. He gets a 0.2. Earlier it was 1, so maybe the order is still in the order, but who gets what address is it defined by the by the router, right? So what is this kind of addressing called? This kind of addressing is called, anybody, any idea what is this kind of addressing called? This kind of addressing is called dynamic addressing. So when you hear about a term DHCP, you're talking about dynamic addressing, dynamic host control protocol or something. So this fellow is responsible. The protocol is responsible to give dynamic addresses as and when people connect on the network, because we are not permanent on any network. No, I may take my phone and connect to a railway network. So the railway network router will give me a different address. When I'm coming to the house and connecting to my home router, so I may get a different address. So the IP address that I'm assigned is always not permanent. Like more of a dynamic addresses that I'm getting it. So most of your devices are assigned dynamic addresses. But in case if you keep on changing the address, nobody will know whether you are 198.100.0.1 this time or your 198.100.0.2. So that is why static addresses are important. So my question is, when is static address important? Static address means one time you give the address, it never changes. When is static address important?
So if I'm not wrong, for Wi-Fi and all we use static address
No.
relay, right?
It is important when you have a particular specific machine to connect to, like your website. So when you have,
VPN.
yeah, so when you have a particular website, right? So let us say let's be ping www.facebook.com. What is the IP address? Okay, I'm not getting. This is a IPv6 address. It looks like. So this is a bigger address if you notice. So the key point is that one time when I visit www.facebook.com, it should always point this is just an English name, but what is the equivalent IP address that I'm trying to connect to? I'm always trying to connect to a box. A box doesn't understand this English term www.facebook.com. A box understands IP addresses. It says I am so and so number. This is my address. If you want to connect to me, specify this number and send the message. That is how somebody will connect to www.facebook.com. So IP addresses have to be static when everybody, lot of people are connecting to your computer using their IP addresses. So if it is like your Wi-Fi network where your phone is coming in and then you're connecting for the internet, it doesn't matter what address you are. You're not hosting any website or something, or where people are connecting to your box. But let's say you're playing a game, and sometimes in a game the central server itself will assign the IP addresses and they will become, they'll connect to each other, so it may work. But sometimes you may just want to make sure you always connect to that particular your phone or your computer. Then static address is important when you want to make sure the IP address is not changing in. So static IP addresses are expensive, because that's why in AWS we have got something known as elastic IP addresses. So you can purchase a set of IP addresses and say my machine needs a static IP address. So every time, when you must have noticed, when you start a machine, when you create a machine, a different address is given, IP address is given. That is dynamic address. It is using DHCP. But let's say if I'm a website, if somebody is connecting to my website, ultimately that name has to be translated into IP address, and that IP address has to be unique. So that's why I use static addressing, and that is why I will purchase a IP address from maybe AWS and assign it to my machine, and say every time somebody connects to my machine, they have to connect using this particular IP address. So why it is elastic? So sometimes, let's say my computer is I want to maintain my computer, I want to take the computer away and replace another computer. So will the IP address change in that case? I don't want to change the IP address in that case. That time I want the IP address to remain the same, only the computer to change. When I'm maintaining some server or something, and I want to want to test my new changes on a different production box. That time elastic IP addresses are very useful. It is elastic means it can be shifted. That same static address can be shifted from this computer over here. Say your website is running on box B, it can be moved over here. So second time somebody wants to reach your IP address, like say www.facebook.com was mapping to elastic IP address 1. So earlier it was reading this computer, but right now, because the IP address has moved over here and been assigned over here, the same IP address is used, but the computer is different now. And this time the facebook.com will everybody will connect to computer number A. So this is usually used in deployment. We say we call it a blue-green technique, deployment technique. So basically, one computer, you already have your website running over here. So but we want to sometimes want to release some changes, which is new changes, but we do not know whether it will work or not work, whether there will be any problem or not problem. So that is the time this blue green deployment technique is used, and that is the time they may use this elastic IP addressing just to change the machine to which the people are connecting to. So when they connect to machine number A, there may be some new changes. When they connecting to machine number B, there may be old changes. If there is some problem in the machine number A which has new changes, they shift the elastic IP address to or back to the original website. So IP address is a logical addressing. MAC address is a is your physical addressing. So in the world of internet, we deal with IP addressing, and every IP address will be mapping to some MAC address for sure. So every logical address will have some MAC address. question comes about then what is internet, right? Then so can anyone tell me what is internet? So this is called this, you can say this is one network. So this is network number 1. Okay. So network you can say host ID equal to 1. So this is quite possible. This is your network inside your house, right? And now you want to connect to some other network. So how will we connect to some other network? So this is where your routers come into place. Okay, your router is mainly to connect one network to another network. Okay, so it will be somewhere on your edge of the network over here. So it may look like a center. So but mostly it is even if it is center, through one router you can travel to another network. So that is what routers are mainly used for. That is where routers come into being. So now when you look at network of the world, this is how it will look like. It will have devices, it will have a communication channel like cables or Wi-Fi or satellite in between connecting the two ends. It will have if it is a kind of a intranet like a closed home network, you will have probably switches may work for you. It will like a LAN system or something, switches will work for you. You don't require so hubs and switches may work for you. You don't require routers. But if you want to if your computer in your network has to connect to some other device in some other network, then you require routers. So here you have device number A. Let's say you have device number B, and let's say you have device number C. What colors did I use? Okay, just let me bring that diagram. Used a brown color. So these are your devices. So how are you going to connect your devices? So these days nobody uses hubs mostly. They mostly use switches. Okay. So how does your switch look like? A switch. So I already showed you how a network interface card looks like. This is your network interface card. Okay. This is on your device, and this will be assigned a particular MAC address, and anybody wants to connect to talk to your device, they have to go through your network interface card using that MAC address. So this is how your switch will look like. There are each opening is like you can connect one wire to your computer. So when you in this there are around maybe 20 switches right inside this. So you can have 20 computers. So this switch is like your central it's like your dadar station, your central station, where one is connecting. You can connect to all the other stations, maybe something in that. So this is your switch. So when I'm drawing the diagram, imagine what a switch looks like. So this is your switch over here. Then what else? Other things I told you about NIC cards, right? Your network interface card. It will be there somewhere, and they will have MAC addresses, and they can be all be connected. These computers can be connected using through switches. And the switch, your router can operate, if it is an advanced router, it will operate like a switch also, it will operate like a router also. But let's say it is not that way. You have a separate router device. So how does a router may look like? So router may look differently, but you must have seen this kind of routers, in your homes, so that is what your router may look like. And what does a router help you to do? It helps you to connect to the outside network, like your internet. So there may be a router over here. So router is like your door to the outside world. Okay. So whenever, let's say, this IP address is number 1, 2 and 3. Suddenly one says I want to send a message to number 4. The switch will say, Array, I don't know who is number 4. So what will the switch do? Switch will go and ask router. Switch will say, do you know number 4? So this fellow, on the other end, you have connected another switch. And you have another set of computers or another set of devices over here. And this router will say, yes, I know number 4, he is on the other side, so let me connect back to you. So that way the router is enabling a connection of your two networks. I'm a little slow in diagram, but as I'm drawing the diagram, I hope you can visualize how things are getting connected. And everyone will have an NIC card, as I told you. Everyone will have a MAC address. Everyone will have a IP address. So this may be one network which says this is 1.1. This fellow will get 1.2 address. This fellow will get 1.3 address. And the other network may be defined using a different address, 2.1, 2.2 or 2.3. So usually our IP addresses will look something like this: 198.100.0.1, something like that. So I'm just giving over here. But the router is helping you connect to different network, and the switches is helping you to connect your internal network. But the question is, now what happens when somebody wants to connect to 3.1? Can anybody tell me? Which is not even existing here. Then what we will do? Anybody there? Can you?
Yes, sir.
Okay. Yeah. So when you,
So can you repeat?
sorry, go ahead.
Can you repeat the question, sir?
Now some device, here we have two different networks, but right now on one side there's 1.1 device with the address 1.1, and it is trying to look out for a computer with the address 3.1 which is not existing in either side of the network. What will the router do? How will router reach that computer?
BGP, there is a protocol they use called BGP. Through that, maybe he'll be able to reach another network.
Yes, so maybe
And
at the software level they may use
yeah,
all that.
router does the role of
Good.
no,
Yeah.
not at software level.
Yeah.
Router anyway
Is
does the role of in the network.
yeah, so what I'm trying to emphasize at the hardware level, it is all about router to router. We're not talking about at a very like any something like the protocol level or the software level, but we are talking about hardware to hardware level, how everything is connected to the entire world. So this router may be connected to another router. So this may be your ISP. This is quite possible. This is your ISP. This is your phone, because your phone is your subscribing to Airtel. Your Airtel has to connect to a tower which is your ISP provider. That fellow will be, so this router may be connected to this router, but maybe this router to router connection is the source of connection, the transmission medium is Wi-Fi over here. It is 4G. So instead of using cable wires to connect the two routers, this time a 4G network has been used to connect to the ISP. This ISP may be connected to another ISP, which is your another router, and that router may be connected to another router. That router may be connected to some switch. That switch may be connected to some device. And what is an internet then? Internet is your network of networks. And how is this network of networks operating? It is operating using devices. It is operating using switches. It is operating using addresses. It is operating using routers. If you have to visualize the network of network, this is all you need. You don't require much more than this. Everything is about routing. From here I'll catch a bus, now I'll catch a plane, and then I will reach this destination. It is all about reaching from A to B. Now whether you're using a cable to connect to two computers, whether you're using a Wi-Fi, whether you're using a remote to TV infrared connection, it doesn't matter. The information is constantly traveling. You may be using a fiber network, with a light as a medium. So the entire world you can imagine as a set of routers. It is all about that. So how does hacking happen then? Hacking can happen if somebody has hacked your router, if somebody has hacked your somehow they have got into your hardware on the way, on the route. They are sniffing it basically. So they're waiting over here to and sniffing all the data that is traveling through your main ISP. That is how your main ISP knows, who is browsing what. And that is why there are techniques like sometimes people use VPN, sometimes people use Tor browser. How they work differently, that is a different concept. But the idea is at the hardware level, this network of networks, internet is all about network of networks. It is not even about browsing, or it is not even about your websites. It is about your network of networks. Okay, so this is what your internet is about. So what is internet? Network of network, and this is how it is all connected. Is there any question or something I didn't cover, or something you all didn't understand? Next, to talk about internet, will you understand in terms of routers and switches? Okay, and Let me see what else is there. So this is what internet is all about. Then what is DNS? The DNS is basically just like your your application. So there may be at some point, somebody this router to router is all about your IP addressing, but somebody nobody understands. Sorry.
Yes, sir. Your screen is not shared.
Oh, just now it went.
Yes, sir.
Okay, no problem. Okay, can you see?
Yes, sir. Now it is.
Yeah, so DNS is like your, it's got nothing to do with your hardware. It is just like you think of it like a software program, and it is like a database you see. So where that database is basically what happens is nobody remembers numbers, what is your pin code and everything. Everybody wants a building name. From the name then I want a city name. From the name I'll get pin code. So DNS is just like maintaining a list of you know English names or English website, English names or whatever language the basically it contains a list of website name and saying this website the IP address is 1.1 something like that. Website maybe my .com. Then there may be another website in the same DNS website. It will be u.com, and u.com where it might be somewhere in another network which is part of connected through some other router. It will be 15.1. So DNS is just a database which tells you this name, this is the IP address. Now where is this IP address located? That is the work of network of networks. That is the work of router to router. That is where all these protocols come into place, which Tuba mentioned about BGP, and there may be some other protocols that may be used. How do you locate a computer where it is in the network? That is a deeper subject of network. But once you are given the IP address, the router is given the IP address. The first duty of the router is to check whether this computer is inside my network. If it is not in my network, which is the next router I will send the address request. This router number A doesn't know where 15.1 is, so he has to decide. He may be connected to 3 other routers. Who knows? Now which router the request should go to? What is the path to locate the address? What is the shortest path to find the address quickly? Should I go through this computer or should I go through this computer? Should I go through this DNS or should I go through some other DNS? There will be multiple DNS databases, and which will be having these addresses. So this is all then comes up to at the website level. So DNS is more about web. It is not about your internet. Internet is about your network of networks, hardware and everything, but web is about your whenever we speak about web, we are talking about URLs, we are talking about HTTP protocol, we are talking about URL is nothing but a name, no? So which is there, that name is there inside your DNS entry, and so these are the detail things which is your HTML will come over here, part over here. So web is all about dealing with HTML pages, CSS, your JavaScript, your HTTP, your URLs. It has got nothing to do with your network of networks. The web cannot work without means of course there is a web that can work without a DNS where people know how to travel the from 1.1 to 15.1. The 15.1 computer will be somewhere over here. Now which computers are there in this line? Somebody must have known all the IP addresses. If you know from Borivali you have to move to Dadar, from Dadar you have to move to Kalyan, from Kalyan you have to move to Pune. if you know the stations where you have to connect to, you know how to reach your destination. So you don't require the DNS all the time. If somebody says how to go to Pune, you, if you know which station to switch, this list of stations to switch, to move, from one location to another location, you don't need a DNS. Then DNS is just to a user friendly way of telling about a particular IP address in a some near English, like English format name, like website like my.com, you.com, they.com, everyone.com, something like that. And it has got nothing to do with networking. If you know the addresses on the way, you will be able to find your way on your own. And this is the technique which is used by your your dark network, because dark network and all this Tor browser, they don't, not all the addresses are stored in the DNS. Nobody wants to be recognized. There are a lot of different, like you can say, illegal activities that is probably going on. No, nobody wants to be there. Let's say they are in a country where they don't want to be identified, or your government has restricted you. But government can say your entry cannot be in the DNS, but government cannot say you cannot reach this computer, because all these computers are connected to each other. The only way of disconnecting one computer to another computer is disconnecting from the internet. You switch off everything, or you don't connect all these cables, you don't have all this Wi-Fi, you don't have this all these satellites, then only then and then only you will not be reachable that way. you know but every country is connected on the internet. They have a door to move out and connect. Some government employees will have a way to connect to the internet, and so if they have a way to connect, then anybody have a way to connect. So that private path, how to follow, can be found out by the hacker, how to travel to computer A to B without touching the DNS. So it is all a matter of one IP address to another IP address. So that is what DNS is all about. That is what web is all about. So now I have covered the entire networking, internet, and web. Any questions on how all these pieces are connected to each other? So these are the basics which you should know, at least minimum, whenever you're getting into operations. So especially with networking and infrastructure. So so that you will be able to explain them what is DHCP, what is DNS, what is switches and routers, and what are NICs. All these questions can come up in a basic interview. So with that, I will wrap up for now, because your time is, I don't want to touch the new topic now. And any feedback on today's session?